Welcome to today's deep dive. We're exploring a thrilling astronomical mystery today, one that is literally sending shockwaves through the scientific community right now.
Yeah, it really is. It's totally
the
upending
telescope
things.
captured
Right.
something
So
inexplicable.
today's sources come from these fascinating
a
excerpts
massive, irregular
titled
drop in
Dyson
starlight.
Spheres and the Mystery of Tabby's Star. And what we have here is this incredible blend of historical astronomical observations from a few years back, combined with cutting-edge space telescope data that just came in.
And that contrast, between the older observations and the brand new data, that is where the real story is.
Exactly. So the mission for this deep dive is to unpack exactly why this one flickering star has baffled scientists for years. And we really want to figure out if this recent data is showing us like space dust or actual evidence of alien engineering.
Which is quite the leap, but the data is pushing us there.
It is. And to start, I want you to just imagine something for a second. Picture yourself looking at a bright street lamp down your road. It's always there, right? Steady. But then suddenly, this massive, jagged chunk of its light just goes completely dark.
Like someone threw a blanket over part of it.
Yeah, exactly. And it happens in this totally unpredictable pattern. You'd stand there wondering, what on earth could possibly be passing in front of it? Okay, let's unpack this.
Right, so to understand the shockwaves being caused by the new telescope data today, we really first have to understand the strange anomaly that started this whole thing a few years ago.
The inciting incident, basically.
Exactly. So we have to go back to 2015, to the Kepler Space Telescope mission. Astronomers pointed their telescopes at this mysterious star, which we now call Tabby's star, and they found something that simply shouldn't exist.
Which is saying a lot in astronomy.
Right. So for context, the baseline for normal stellar behavior when you're looking for planets using what's called the transit method is that when a planet passes in front of a star, the star's brightness only dips slightly.
Right, like microscopically.
Yeah, even a massive gas giant like Jupiter passing in front of our sun, that would only block about 1% of the light. But Tabby's star, its light was dropping in massive, irregular patterns. We're talking dips of up to 22%.
See, 22% is it's wild. Planets absolutely do not block 20% of a star's light.
No, they don't. It's physically impossible for a planet to do that.
Right, so to make this relatable for you listening, if a normal planet is like a mosquito passing in front of a flashlight, whatever is orbiting Tabby's star is like a giant, oddly shaped beach ball, just flying right in front of it.
That's a great analogy, actually, because a sphere that large, it would have to be nearly half the size of the star itself.
And a body that massive wouldn't even be a planet anymore,
Right.
right? It would trigger nuclear fusion. It would just be another star.
Exactly. It would be a binary star system glowing on its own, not just blocking light. Plus, planetary transits are smooth, they're symmetrical, they make a nice U-shape on the graph because planets are spheres.
Right, they happen on a regular schedule.
Yeah, but the dips here were jagged, highly asymmetrical, completely random.
And this defies all models of natural stellar behavior, which is why this matters so much to you, the listener. It proves that our universe still holds these massive secrets that can completely break our established scientific models with just a single observation.
It really shattered the paradigm. And since a giant planet couldn't possibly explain a 22% drop in light, scientists had to, scramble for natural alternatives before jumping to wild conclusions.
Because you can't just yell aliens right away.
Right. The scientific method demands we look at natural theories first. So mainstream astrophysicists hypothesized that the dimming was caused by a massive swarm of comets, or maybe a giant cloud of space dust passing by.
Which sounds plausible on the surface, I guess.
It was the safest bet at the time. But now we have a massive data shift. NASA recently pointed the James Webb Space Telescope, which is vastly more powerful, right at these exotic stellar dip patterns across the galaxy.
So Webb is doing a deep analysis. But from millions of miles away, how can a telescope possibly tell the difference between a cloud of dust and, well, something else?
What's fascinating here is that the James Webb Telescope uses high-precision spectral data. It doesn't just measure the amount of light. It breaks the light apart into its chemical fingerprint.
Okay, so it separates the wavelengths.
Exactly. And this new data proves that the light patterns do not match simple dust.
Because the way dust scatters light, right? Like Fine space dust particles are about the same size as visible light wavelengths, so they cause Rayleigh scattering
Which means they scatter the shorter blue wavelengths.
and let the red slip through, just like how we get red sunsets here on Earth.
Right. If it were a giant comet swarm or a dust cloud, the star's light would look distinctly redder during the dips. But the Webb data showed the exact opposite.
No redshift at all.
None. The data shows a panchromatic full-spectrum blockage. The light is being stopped completely across all wavelengths evenly.
Wow, so it's not like looking through tinted glass. It's like someone dropping a brick wall in front of the star.
That is precisely what the spectral data tells us. The objects blocking the light are structured, non-spherical, and completely opaque.
And since the James Webb data points to structured non-spherical objects rather than simple natural dust, scientists are just being forced to seriously consider non-natural engineered explanations.
They don't have a choice. The natural models are failing to explain this.
Okay, here's where it gets really interesting. I want you to imagine an engineering project so mind-bogglingly massive that a civilization builds it to completely encase their home star, just to harvest 100% of its energy.
Right, the Dyson Sphere hypothesis.
Yes, the Dyson Sphere. It's a massive leap, but we have to talk about it now.
And this brings in the concept of a Type 2 civilization. So the sources discuss the Kardashev scale, which measures how advanced an extraterrestrial intelligence is based on their energy use.
Humanity is barely approaching Type 1, right?
Yeah.
We just use planetary resources.
Barely. But a Type 2 civilization is an incredibly advanced extraterrestrial intelligence capable of these hyper-advanced artificial engineering feats. They can harness the total output of their entire star.
But I do want to push back on the classic image of a Dyson sphere.
Mm-hmm.
People always picture a solid metal shell around a star, but physics-wise, that's impossible. It would shatter or drift and crash right into the star.
Oh, absolutely. The scientific community and Freeman Dyson himself actually envisioned what we call a Dyson swarm.
A swarm, right?
Yeah, millions of dense, independent orbital structures, massive solar panel arrays, energy collectors, orbital habitats, all flying around the star.
So if we connect that back to the James Webb data, millions of opaque, solid objects in chaotic orbits would block 22% of the light evenly, without a redshift.
Exactly. If we connect this to the bigger picture, those non-spherical structured objects the telescope is detecting could literally be the solar panel arrays of aliens. A partial Dyson swarm fits the observed light curves perfectly.
Which is just staggering to think about. But with these mind-bending possibilities on the table, space dust versus alien megastructures, how is the scientific community actually handling this data?
Well, there is a fascinating divide right now between the skeptics and the math. The skeptics are firmly holding their ground.
They usually do.
Yeah, they are continuing to search for rare, highly complex natural explanations rather than conceding to the existence of alien technology.
And I get that. I'll play devil's advocate for a second. There's a human tendency to jump to aliens whenever we see something in space we don't understand.
Right, the classic aliens of the gaps fallacy.
Yeah, like when they found the first pulsar and literally labeled it LGM-1 for little green men. But even with that caution, I have to admit, the specific shape and opacity of these objects makes it incredibly difficult to just ignore the artificial hypothesis here.
It does. And this raises an important question, because on the other side of the debate, the mathematical signature of artificiality remains the absolute strongest and most thrilling possibility for these cosmic light dips.
Because they ran Fourier transforms on the data, right?
Yes. They analyzed the hidden periodicities in the light dips. In nature, gravity enforces regular harmonic cycles. A natural debris field will eventually settle into a uniform resonant orbit.
It's just how gravity works.
But the mathematical signature here shows a total lack of harmonic resonance. It's profoundly irregular. The math strongly points toward artificiality.
Which puts you, the listener, in a really interesting spot. Are you siding with the skeptics waiting for a natural explanation? Or does the mathematical signature convince you that we're looking at something engineered?
It's the tension between humanity's desire for a simple, natural answer and the cold, hard mathematical data.
Exactly. So to recap the incredible journey of this deep dive, we went from a baffling 22% dip in Tabby's star back in 2015, all the way to James Webb's high-precision spectral data that completely ruled out simple dust.
Leaving us staring right at the awe-inspiring possibility of Type 2 civilizations building Dyson swarms.
So what does this all mean? It means that whether these light dips are caused by insanely complex, undiscovered natural phenomena or hyper-advanced alien solar panels, our galaxy is far more exotic than we ever realized.
It certainly is.
And I want to leave you with a final thought to mull over. If a Type 2 civilization is actually out there building massive structures to harvest 100% of an entire star's energy, what unimaginable technology or colossal task could possibly require that much power?
It's a terrifying and thrilling thought.
What on earth are they plugging in? Thank you so much for joining us on this deep dive. Until next time, stay curious.